Good evening, students. Welcome to day 9 POC-II crash course. Thank you so much for joining. So in today's session, I'm going to explain about some of the most important analytical constants of fats and oils. Again, this is one of the definite question in your final examination. In yesterday's session, I have discussed about some of the most important reactions of fats and oils. So hydrolysis or saponification, rancidity, drying of oils and hardening of oils. These are the 4 important reactions I discussed in yesterday's session. So if you have missed yesterday's session, then replay will be available. You can watch the replay. And if you have any doubts, then there will be a WhatsApp group link will be given in the description. So you can join in that WhatsApp group and clarify your doubts. Stay with me till the end of this session. Today also at the end of the session, I'll be discussing about some of the important examination questions and I'll be giving you guidelines exactly how you have to write so that you can get maximum marks. So during this particular session, whenever you get any doubt from time to time, you can type your doubts in chat. Alternatively, if you are watching the replay of this particular live session, then a WhatsApp group link will be given in the description of this particular session, and you can join in that WhatsApp group and you can ask your doubts at any point of time. Quiz will be enabled at the end of this session. So once the session is completed, review today's concepts, whatever I am going to discuss now for about 15 to 20 minutes, then attempt the quiz. Now, without wasting much of your time, let's get into today's topic. So first, I'll be discussing about acid value. And before that, I'll be just listing out all the analytical constants which are given in your syllabus. Acid value, saponification value, ester value, iodine value, acetyl value, and rich and micelle value. So these are some of the important analytical constants of fats and oils which are given in your syllabus. And by determining these analytical constants for the given fat or oil, we can determine the purity of the fat or oil. So each of these analytical constants will be discussed under 3 headings. The first and most important thing is definition of these analytical constants. So when it comes to acid value, what is the proper definition given for acid value and what is the significance of acid value and how we can determine the acid value, which includes both principle as well as procedure. Now let's first begin with acid value. So whatever the analytical constants related information that I am going to provide in this particular module, that is in terms of definition and the procedures, were taken from IP 2022. Now the definition for acid value is, it is the number of milligrams of alkali, that is potassium hydroxide, which is necessary to neutralize free fatty acids present in 1 gram of fat or oil. Now let us see first how we can determine this particular acid value. Now let us try to understand the definition of acid value first. So usually these fats and oils are nothing but triglycerides because they are the esters of glycerol and fatty acids. While preparing these triglycerides or triesters, sometimes free fatty acid content may be left over as impurity in these fats and oils. So these free fatty acids which are left over in the fats or oils will cause adulteration or rancidity of these fats and oils. So by determining this acid value, we can identify how much of free acid is left over in the fat or oil as an impurity, because which is the one which is ultimately responsible for the rancidity or adulteration of the sample. So in that way, we can identify the purity or quality of the given sample. Now, how we can determine it? Because we know that we want to determine the free fatty acid content. So a specific quantity of the oil sample as per the monograph specifications will be taken and it is titrated again as standard alkali by using a suitable pH indicator such as phenolphthalein. That means when we titrate the given oil sample by using potassium hydroxide using suitable indicator, an acid-base reaction occurs because potassium hydroxide is a base and we want to determine the free fatty acids. That is nothing but the ester component, and thus it results in the formation of corresponding salt. So thus the principle involved in acid value determination is a direct acid-base neutralization titration. Now students, I strongly recommend you to pause this video at this particular stage for half a minute and think about the reaction, what type of reaction that we can write for this particular acid value determination by considering this principle. Now you understood that you are going to take potassium hydroxide in the burette, okay, and oil sample in the conical flask. So now we want to determine the free fatty acid. So you can represent the free fatty acid structure like a general carboxylic acid structure. Then add potassium hydroxide and write the structure of the resulting salt. So I hope you might have done this particular exercise. Again, for your clarity, I'm giving the reaction here. So we can just write this particular simple reaction to represent the acid-base neutralization in the acid value determination. So what is the thing that we want to determine? We want to determine the free fatty acid content. So basically it is an acid. So we can represent that with RCOOH, and we are titrating with base. So you can write potassium hydroxide formula. So as a result of this acid-base reaction, it gives corresponding salt. So write the structure of salt of the fatty acid, that is potassium salt of the fatty acid, as RCOOK. So now in this neutralization reaction, there will be formation of water as byproduct. So you can represent the reaction under principle like this. Now let us consider the procedure involved in the acid value determination. So step 1, take the sample in the conical flask. And how much of sample that you are going to add, that depends on the monograph specifications. For each and every oil, whether it is a coconut oil, castor oil, mustard oil or olive oil, how much of sample you have to take. These particular information is provided already in the IP. So as per those IP specifications, you will be measuring the oil sample and take that into a conical flask, which is containing a mixture of ethanol and ether. Usually in any analytical procedures or titrations, we try to dissolve the samples in water. But here, as you are aware, fats and oils are water repellent in nature, and they are soluble in only organic solvents. That is why we will try to avoid water here, and we always use organic solvents like ethanol, ether or chloroform. So in the acid value determination, we have to dissolve the specified amount of the oil sample into a mixture containing equal amounts of ethanol and ether. Now, another important point here is whatever the free fatty acids which are left over as impurity in the given sample, we want to determine in the acid value. So, if any acidic components are there other than the sample, they should be previously neutralized. That is the reason whatever the solvent mixture that we are using in this particular experimentation, that is mixture of ethanol and ether, should be neutralized first. Okay, so this previously neutralized solvent system will be used to dissolve the oil sample. Now, once sample solution is ready, in step 2, just add phenolphthalein indicator. So after adding the phenolphthalein indicator, just titrate this particular sample again as potassium hydroxide. So we have to continue the titration by using potassium hydroxide till we get the endpoint. Now the next question, what is the endpoint in this particular reaction? So make a note of color change here, students. So when you add phenolphthalein indicator to your sample, you are expecting that free fatty acids are present in your sample. So in the presence of acidic environment, phenolphthalein shows usually colorless. After certain volume rundown, neutralization occurs. Now once neutralization, that means all the free fatty acids will be neutralized by the added potassium hydroxide. Now once neutralization point reaches, now whatever the next drop of potassium hydroxide that you are adding, due to the excess of potassium hydroxide, the pH in the conical flask, it becomes basic. Okay. Now, in the presence of basic environment, phenolphthalein shows pink color. That means how to identify the endpoint here. Once you get pink color, immediately you have to stop the titration. So endpoint in this particular reaction is colorless to pink. So as soon as you get pale pink color in the conical flask, stop titrating with potassium hydroxide and note down the volume rundown. And substitute this volume rundown in the formula given. Now what is the formula for the acid value determination? So this is the formula for acid value determination. That is 56.1 multiplied by volume of potassium hydroxide. That means whatever the volume rundown is there, that you will substitute here, multiplied by the molarity of potassium hydroxide used. What is the molarity of the potassium hydroxide that you are using in the titration? You should substitute here, divided by weight of the sample. Okay, multiplied by the molarity of the standard potassium hydroxide. So here two molarity terms are there, students. One molarity term is in the numerator, another molarity term is in the denominator. Okay. Because potassium hydroxide is a secondary standard, whenever you are using potassium hydroxide in a titration, you have to determine its molarity. So that means you have to perform the standardization of potassium hydroxide also along with acid value determination. So whatever the value that you are getting there under standardization of potassium hydroxide, that is the actual molarity of potassium hydroxide used. So that term will come in the numerator. As per IP specifications, we are supposed to use 0.1 molar potassium hydroxide. That means 0.1 molar term will be coming in the denominator. Now this 56.1 is the equivalent weight factor for the potassium hydroxide. So this is how, by determining the volume of potassium hydroxide, just by substituting that value in the formula, we can determine the acid value. Now that we have learned the definition of acid value and how we can determine it, let us try to understand its significance. Acid value indicates purity of the oil, because lower the acid value, better the quality of fats or oil. Any deviation in the acid value, it indicates rancidity. So in that way, rancidity of the given sample can be identified by determining acid value. And also the storage quality of the given sample and also its suitability for pharmaceutical use can also be determined by determining its acid value, because higher the value, more will be the degradation. If any sample is undergoing degradation during its storage condition, obviously it gives higher acid value. This indicates that the oil sample is a stale oil, which is nothing but the oil is stored under improper conditions. So in this way, by determining acid value, we can identify the purity of the given oil or fat sample. So I hope students, acid value determination is clear to you from this particular discussion. So dear students, at least try to learn what is the definition for acid value, its formula and its significance. That is more than enough. Okay. So whenever you are learning any topic, just learn what is what first, then go deep. Okay. If you are confident enough about what is what, then you go deep. Okay. So then you can learn about its determination, which involves acid-base neutralization, direct titration. Okay. So if you have any doubts related to this topic, you can type your doubts in the chat. Meanwhile, I'll share my screen to discuss about the next important topic, that is saponification value. So the definition for saponification value is, it is the number of milligrams of alkali necessary to neutralize the free fatty acids and to saponify the esters present in 1 gram of fat or oil. Now let us try to understand the meaning of this saponification value through its determination. The principle involved in the determination of saponification value is neutralization, residual titration or back titration. So let us see what we are going to determine in this saponification value. So fat or oil are nothing but triglycerides. That means they are triesters. And they also consist of sometimes free fatty acids as the impurity, which is the main one responsible for its rancidity or adulteration of the given sample, which I explained under acid value determination. Now the esters which are present in the given sample of fat or oil can be subjected for alkaline hydrolysis. So this alkaline hydrolysis is nothing but the saponification, which is mentioned in its definition. So upon saponification or alkaline hydrolysis, esters will undergo cleavage, as a result of which they give corresponding fatty acid as well as glycerol. So this particular reaction was clearly explained under hydrolysis or saponification in the earlier course video. So you can refer to that course video to get better clarity about this particular concept. Now, along with the triglyceride or triester, the fat or oil is also consists of some of the free fatty acids. Because these free fatty acids are having acidic property, we can subject them for neutralization. That is, by titrating with base, we can perform a neutralization reaction so that the free fatty acids which are available in the sample will be converted to corresponding salt. That means both for alkaline hydrolysis or saponification and also to perform the neutralization of free fatty acids, here we will be using base. That is what is mentioned in the definition of saponification value. So it is the number of milligrams of base or alkali, which is nothing but potassium hydroxide, required to neutralize the free fatty acids and to saponify the esters present in 1 gram of fat or oil. So to determine how much of alkali is required to perform the saponification, that is alkaline hydrolysis, and also to neutralize the free fatty acids present in the given sample of fat or oil, we will do titration. That means we will do volumetric estimation. So here, to get to know about these two things, a known excess of potassium hydroxide will be added to the fat or oil sample. Then it is subjected for heating. If we want to determine only free fatty acids, then we can just titrate the given oil sample by using potassium hydroxide, utilizing an acid-base direct titration like acid value determination. But here, along with the neutralization of the free fatty acids, we want to saponify the esters which are present in the oil sample. So in order to perform the saponification, we need to heat the given oil sample by adding alkali. So whatever the remaining base is retained after heating process is back titrated by using standard acid such as hydrochloric acid using suitable pH indicator. For example, phenolphthalein. And also here we will be performing a blank determination to determine the saponification value. Now students, pause this video for a minute and try to write the reaction for this principle. So as you have written a reaction for acid value, here we will be neutralizing the free fatty acids. So you can, whatever the reaction that you have written under acid value, the same reaction comes for the second part. Well, the first part is alkaline hydrolysis. So as a result of alkaline hydrolysis, ester gets converted to fatty acid and glycerol. And the same reaction was discussed under earlier course video under alkaline hydrolysis or saponification. So you can write the same reaction here under principle of this particular saponification value. That means you will be writing one reaction corresponding to the saponification and other reaction corresponding to the neutralization of the free fatty acids. So I hope by this time you might have written. So for your clarity, I'm giving those two reactions here. So here the first reaction is corresponding to the saponification reaction, which I mentioned earlier. So this is the structure of fat or oil. So alkaline hydrolysis is performed. So it is a single step reaction where we will be getting glycerol. So this part will be cleaved as glycerol and the corresponding soaps, that is salts or fatty acid, will be formed as products. Okay, now coming to the second part, that is neutralization of the free fatty acid. So this is the general structure of the free fatty acid. Again, potassium hydroxide is added. So we get the corresponding salt. So these two reactions are corresponding to the two processes which I mentioned in the earlier slide. Now let us try to understand the procedure involved in this saponification value determination. So first step, as usual, we have to take the oil sample as per the monograph specifications. So weigh accurately about 2 grams of the sample to be examined and transfer into a reflux flask. It is not conical flask here. Why? Because we are going to reflux or heat the oil sample along with potassium hydroxide in order to facilitate the saponification process. That's why as soon as the sample is weighed, transfer the sample into a reflux flask. Okay, now you add excess of potassium hydroxide. So here we will be adding 25 ml of 0.5 molar ethanolic potassium hydroxide solution. Okay, now whenever we prepare potassium hydroxide in analytical titrations, it is usually dissolved in water. But because the given oil sample is water insoluble in nature, here we will be using ethanolic potassium hydroxide solution as the base here. Okay, now then add pumice powder or porcelain chips in order to avoid bumping during the reflux process. So as soon as potassium hydroxide is added, then attach the reflux condenser and reflux the contents on water bath for about 30 minutes. Now during this process, what happens? As soon as you add potassium hydroxide, neutralization of free fatty acids which are available in the sample occurs, and during this 30 minutes heating process, saponification occurs. Okay, that means esters will undergo cleavage. So at the end of the 30 minutes, all these two processes will be completed. That means your sample is now ready for the titration. Now at this point of time, add 2 drops of phenolphthalein indicator and titrate the contents of the flask immediately by using 0.5 molar hydrochloric acid. Once you get endpoint for this titration, note down the volume rundown as AML. Now again perform blank titration. So what is the meaning of blank titration? That means we will be repeating the same titration by omitting the sample. That means we need not to do the first two steps. So perform the blank titration by third step onwards. Okay, that means you will be adding 25 ml of 0.5 molar ethanolic potassium hydroxide and porcelain chips. Then boil the contents for 30 minutes, add phenolphthalein indicator and titrate by using hydrochloric acid. Now, in this particular titration, whatever the volume rundown is there, consider it as BML. Okay, so A is the initial volume, okay, and B is the value corresponding to the blank titration. Now, what is the end point of the titration? So, when you add phenolphthalein indicator, what is the pH of the solution? If you see, there will be excess of potassium hydroxide will be left over. So due to the presence of excess of potassium hydroxide, the pH of the media, it becomes basic. Now in the presence of basic medium, phenolphthalein shows pink color. That means whenever you add phenolphthalein indicator to the reflux flask or to the conical flask, the solution immediately it becomes pink. Now once you start titrating with HCl, slowly whatever the leftover potassium hydroxide will be there, that will undergo neutralization. Now once neutralization point is reached, now if you keep continuing the titration, now whatever the excess drops of hydrochloric acid added are there to the flask, because of this excess of hydrochloric acid, the pH of the environment, it becomes acidic. Now in the presence of acidic pH, phenolphthalein shows colorless. That means the end point in this reaction will be pink to colorless. Now, whatever the A value and B value are there in this particular titration, we will be substituting these values in the formula given for the saponification value. Now the formula for the saponification value is 28.05 multiplied by the titer value. Here the titer value means it is the difference between the blank titration, whatever you are getting in the blank determination, and the actual value, actual assay value, whatever you are getting. So we'll be doing B minus A, that is considered as the titer value, multiplied by the molarity of HCl used, divided by weight of the oil sample, multiplied by molarity of standard hydrochloric acid. So again, students, here also two molarity terms are used, one in the numerator and another one is in the denominator. Because hydrochloric acid is a secondary standard, whenever we use hydrochloric acid in the titrations, so in the same determination, that means along with the determination of saponification value, you have to perform the standardization of hydrochloric acid also. So whatever the molarity value you are getting for hydrochloric acid upon standardization, so that value is the actual molarity of hydrochloric acid used. So that value comes in the numerator. Now, whatever the standard hydrochloric acid molarity is mentioned in the IP, okay, so the IP, it suggests to use 0.5 molar hydrochloric acid. So this value comes in the denominator. So that is the difference between the molarity terms in the numerator and the denominator. So here 28.05 is the equivalent weight factor for potassium hydroxide corresponding to 0.5 mole. So by substituting the titer value, molarity terms and weight of the sample in this particular formula, we can determine the saponification value of the given oil or fat sample. Now that you have learned the definition of saponification value and its determination, which includes principle and procedure, now let us try to understand the significance of this saponification value. So higher or lower saponification value indicates adulteration of the sample. That means each and every fat or oil will be having its own characteristic saponification value. Any deviation from this value indicates adulteration of the sample. And this saponification value also gives information about molecular weight of the fats, because lower the saponification value, higher will be the molecular weight of the sample. So indirectly we will come to know the molecular weight of the given fat or oil sample. So by determining this saponification value, we can determine how much of alkali is needed to perform this saponification of the ester. So because upon saponification of esters, we will be getting soaps, and this particular information will be useful in soap manufacturing industry. Now let us see how we can determine the ester value also. So what is the definition for ester value? It is the number of milligrams of alkali, that is potassium hydroxide, necessary to saponify the esters present in 1 gram of fat or oil. So once slowly read this particular definition, students. So here we want to determine the alkali which is needed to saponify the esters present in 1 gram of the given fat or oil sample. Okay, so this particular definition of ester value is also similar to that of acid value and saponification value, no? So let us try to compare this definition with saponification value and ester value. So once again, try to recollect what is saponification value. It is the number of milligrams of potassium hydroxide required to neutralize the free fatty acids present. Okay, this is first part. And to saponify the esters present in 1 gram of fat or oil. Similarly, what is the definition for acid value? It is the number of milligrams of potassium hydroxide needed to neutralize the free fatty acids present in 1 gram of sample. Okay. Once you perform saponification value, that means it also indirectly includes acid value determination. Because in acid value, will determine how much of alkali is needed to neutralize the free fatty acid present in the 1 gram of oil sample. Now, even in the saponification value also, we will determine the alkali that is needed to neutralize free fatty acids. So, this one and one component is similar. Okay, but where the difference comes, along with the alkali required to neutralize free fatty acid, we will come to know how much of alkali is needed to saponify the esters. That means whatever the value we get in saponification value, it indicates both. We are not determining separately. Okay. Now, what is the definition for ester value? If you see, it is the number of milligrams of alkali required to saponify the esters present. So, this is saponification. This is also saponification. Okay. That means the ester value determination is also related to acid value and saponification value. Now, if you have a combination of 1 and 2 values, and if you have one value separately, how you can determine 2? Okay, 2 means that is how much of alkali is needed to saponify the esters. Okay, so based on these definitions, you can easily make out how you can determine the ester value. Have you made any guess? Okay, let me clarify it. So when we are performing saponification value, we will come to know how much of potassium hydroxide is needed to perform both 1 and 2 processes. Okay, but what we want is we want only how much of alkali is needed for the second process. Okay, now if we have acid value also, we will come to know exclusively how much of alkali is needed to neutralize or to perform the first process. Then what we can do is just subtract the acid value from saponification value. Once you subtract the acid value, this value from saponification value, we will get the value for 2. That is the alkali needed to saponify the ester. That is what is needed under ester value. If you want to determine ester value, you need not to do any extra exercise, provided if you have already saponification value and acid value available. Okay, just subtract acid value from the saponification value so that you can get the ester value for the given fat or oil. For the given sample, if you have not determined saponification value or acid value, then in order to perform the ester value, first we have to perform saponification value and also acid value. So that by subtracting one from the other, we can get the ester value for the given fat or oil. So dear students, I hope saponification value determination is clear to you from this discussion. So saponification value is mainly useful for manufacturing of soaps and also molecular weight determination. Okay. So if you have any doubts related to this topic, you can keep your doubts in the chat. So you can keep your doubts in the chat. Meanwhile, I'll be taking up the next important analytical constant, that is iodine value determination. So let me share my screen. So iodine value is the number of grams of halogen calculated as iodine, which is absorbed by 100 grams of fat or oil under examination. Now let us try to understand the significance of iodine value and also its determination. So its determination basically involves redox titration. Because if you recollect once again, wherever iodine is involved in any titrations, they belongs to the class of redox titrations. And here iodine value determination is an iodometric back titration. So it is also known as indirect iodine titration or liberated iodine titrations. Whenever the given fat or oil sample is treated with the reagents iodine monochloride and potassium iodide, there will be liberation of iodine. So this liberated iodine will be back titrated by using sodium thiosulfate using starch as indicator. So here iodine acts as an oxidizing agent and sodium thiosulfate is a reducing agent, and that is how the principle involved in the determination of iodine value is the redox titration. Because it involves liberated iodine, it is a type of iodometric back titration. Now let us try to understand this iodine value principle with the help of a schematic representation. So the given fat or oil may consist of unsaturated double bonds. So when the given sample is treated with any halogenated reagent in the presence of potassium hydroxide, then it causes liberation of iodine. That means the number of moles of iodine liberated in this particular reaction, it depends on the degree of unsaturation of the given sample of fat or oil. So once we know how many moles of iodine are liberated during this particular reaction, based on that we can make out the degree of saturation or unsaturation of the given oil or fat sample. Now how we can determine how many moles of iodine are liberated? That is by titrating the liberated iodine by using 0.1 molar sodium thiosulfate using starch as indicator. Okay, and by using the volume rundown here, we will be calculating the iodine value. So here basically reaction occurs between iodine and sodium thiosulfate. One is oxidizing agent, another one is reducing agent. And that is how the principle involved in this particular titration is redox titration. So this iodine value can be determined by 3 methods which are suggested by IP. They are iodine monochloride method, which is also known as Witt's method. So in this method, iodine monochloride will be used as reagent. Now in the second method, which is known as iodine monobromide method, iodine monobromide will be used as reagent. The third method utilizes pyridine bromide as the reagent. Hence it is known as pyridine bromide method. Whatever may be the method that is used, whether it is iodine monochloride, iodine monobromide or pyridine bromide, all these are considered as halogenated reagents. So when these reagents are used in the presence of potassium iodide, they cause liberation of iodine. Hence, the principle involved in any of these methods is common, that is redox titration for the iodometric back titration. So out of these 3 methods, Witt's method is very important method, and hence the same method I am going to discuss in the next coming discussion. So in this WITS method, as I mentioned earlier, the reagent used is iodine monochloride solution. So which is represented with ICl. So here we will be adding excess of iodine monochloride to the given sample of fat or oil. Then the iodine monochloride reacts with the unsaturated double bonds present in the given fat or oil sample. So this iodine monochloride reagent will be added across the doubly bonded carbon atoms. So iodine gets attached to the one carbon and chlorine gets attached to the other carbon. That is how an unsaturated compound gets converted to saturated compound. So here we are using excess of iodine monochloride. That means only some of the added iodine monochloride, it will be utilized to saturate the fat or oil. And some amount of iodine monochloride will be left over in the iodine flask. When we add potassium iodide to the reaction mixture, then the remaining iodine monochloride, it reacts with potassium iodide and causes liberation of iodine with the formation of potassium chloride as the byproduct. So here the number of moles of iodine liberated gives us indication about the remaining iodine monochloride. And the remaining iodine monochloride gives us information about the degree of unsaturation present in the given fat or oil sample. To determine how much of iodine is liberated, it will be again titrated by using sodium thiosulfate in the next step. So the liberated iodine is estimated by using 0.1 molar sodium thiosulfate. So this is this pretty much same reaction which you might have learned under standardization of iodine or reaction of sodium thiosulfate with iodine in your pharmaceutical analysis or pharmaceutical inorganic chemistry in your first sem B pharmacy students. So iodine reacts with sodium thiosulfate in the presence of starch indicator and thus it forms sodium tetrathionate with the formation of 2 moles of sodium iodide as the byproduct. Sodium thiosulfate is used as titrate in this reaction. That means we will be taking sodium thiosulfate in the burette. So the volume of sodium thiosulfate, whatever is consumed, it gives information about the liberated iodine. Further, the liberated iodine gives us information about the degree of unsaturation present in the fat or sample. But here iodine will be liberated corresponding to the remaining iodine monochloride. But as per the definition of iodine value, how much of iodine monochloride is utilized for the saturation of the unsaturated double bonds which are present in the fat or oil is important for us. So in order to determine how much of the iodine monochloride is actually utilized by the fat or oil sample, we have to perform a blank titration. So here blank titration is performed to determine the volume of the reagent which is actually consumed by the sample. And that is why the principle is iodinometric back titration. Now let us see how we can perform this experiment. So a specified amount of the sample is weighed and it is transferred into iodine flask as per the monograph specifications. Now to this particular sample, 10 ml of carbon tetrachloride and 20 ml of iodine monochloride solutions are used. So here carbon tetrachloride is the organic solvents. So as I mentioned earlier, fats or oils are water repellent in nature and they usually soluble in organic solvents. So here carbon tetrachloride is one of the halogenated solvent and organic solvent. It is used to dissolve the given oil or fat sample. And iodine monochloride is the actual reagent used in this particular reaction. Now once we add iodine monochloride, immediately we have to stopper the flask and keep this particular iodine flask under dark at low temperature for about 30 minutes. So observe one important point here students. So in case of acid value determination, saponification value determination, we will be taking the sample in the conical flask. But in the iodine value determination, we are supposed to take the sample in the iodine flask. Because this is a liberated iodine titration, as soon as iodine is liberated, if you perform this reaction or titration in a conical flask, the liberated iodine will be escaped. Okay, and that is why to avoid this particular experimentation error, we are supposed to perform this particular titration in an iodine flask. Imagine iodine flask students. So once this 30 minutes is completed, we should add potassium iodide solution. Now it is not like that suddenly you open the flask and add directly potassium iodide. So slowly the stopper of the flask should be loosened and it should be tilted up so that we will be getting something like cup-like structure here at the top of the iodine flask. So the potassium iodide solution should be slowly added into the cup top of the iodine flask. Okay, because as soon as you add potassium iodide, it reacts with the remaining iodine monochloride and it liberates iodine. The liberated iodine immediately escapes through the opening whatever is present. That is why we have to just slightly tilt the opening or the lid up, and in the cup top we have to add the potassium iodide. As soon as the addition of potassium iodide is completed, immediately close the stopper and swill the flask so that it will be evenly mixed up with the contents of the flask. So this is how we have to add the potassium iodide solution to the reaction mixture. So once the addition of potassium iodide is completed, then rinse the stopper and the sides of the flask, that is iodine flask, with 100 ml of water. Then shake the contents of the flask and immediately titrate with 0.1 molar sodium thiosulfate solution. So whenever this iodine sodium thiosulfate titrations are involved, we don't add starch indicator initially. Okay. Once the yellow color of the solution becomes faint, then add either 0.5 ml or 10 drops of starch mucilage and continue the titration by using 0.1 molar sodium thiosulfate solution till we get the end point. Disappearance of blue color indicates the end point of the titration. So once endpoint is reached, immediately note down the volume of thiosulfate rundown and consider it as AMI. Now perform the blank titration. That means whole titration is continued without the sample. Now whatever the volume rundown that we get at the endpoint in this blank determination is considered as BML. Now these values, whatever we obtain for A and B, we will be substituting in the iodine value formula. Now this is the iodine value formula. So iodine value equals to 0.01269 into 100, which is multiplied by titer value, which is nothing but B minus A. Okay. Multiplied by the molarity of the thiosulfate, that is the actual molarity of the sodium thiosulfate, whole divided by the weight of the sample multiplied by the standard molarity of sodium thiosulfate. That means standard molarity here is, as per IP, we are supposed to use 0.1 molar. So this standard molarity term, it becomes 0.1 molar. Weight of the sample, that will be present in the monograph specifications. As per monograph specifications, we will be weighing the sample. So the same value comes here. So this 0.01269 is the equivalent weight factor with respect to the 1 gram of fat or oil. Because as per the iodine value definition, it should be calculated for 100 grams. It should be multiplied with the 100 grams. So in some of the literature, this whole term will be given as 1.269 also. In that case, you need not to again multiply it with 100, because when you multiply this value with 100, you will get 1.269 directly. Okay. Now coming to the titer value. Titer value is the difference between the blank value and the actual determination value. So B minus A, whatever the value that we get, we have to give here. So this is how, by incorporating A value and the blank determination value and the equivalent weight factor and the molarity terms, weight of the sample, we can determine the iodine value. Now that you have learned about the definition and the determination of iodine value, now let us try to understand its significance. As I mentioned earlier, iodine value is the measure of degree of unsaturation of the given fat or oil. And also, it gives information about drying character of the given oil sample. Oils can be divided into drying oils, semi-drying oils and non-drying oils depending on their drying character. So this particular concept was explained under drying of oil. So if you have any confusions about this, you can refer to that particular course video. So here are the examples which I gave there also. The same examples were mentioned here. Okay. So how we can identify whether the given oil is a drying oil or non-drying oil is based on their iodine values. Usually, drying oils will be having more than 120 as iodine values. For semi-drying oils, the value will be 105 to 120. And for non-drying oils, the value will be in between 85 to 105. So, once we determine the iodine value, we have to see under which range it is lying. Depending on that, we can identify the drying character of the given fat or oil sample. And also, determination of iodine value helps us to find out the adulteration. For example, for almond oil, the iodine value should lie between 85 to 105. So if it is not coming within this particular range, that means the sample is adulterated. And that is how we can even find out the adulteration of fat or oil. Dear students, I hope iodine value determination is clear to you. So again, iodine value also, when you are learning it first time, learn its definition, its formula and its significance. Okay. So then once you are confident about these things, then only you go into the determination. So if you have any doubts related to today's topic, you can type your questions or doubts in the chat, students. And if you are a student who are watching this particular session as a replay at later stage, in between the session, if you are getting any doubts also, there will be a WhatsApp group link given in the description of this video. You can join in that WhatsApp group and you can clarify your doubts. Due to time restriction, I could not take the other analytical constants, but these three analytical constants, whatever I discussed in today's session, are very, very important. Out of these three topics, there is a definite question you will be getting in your final examinations, and sometimes you may get even 2, 3 from this also. One 2 marks question and one 5 marks question also. Okay, that is acid value significance as 2 marks question, and saponification value or iodine value determination under 5 marks question. So like that also, these three topics are very, very important. Now, let me share my screen to show you some of the important questions, model questions, how the questions have been asked in the previous question papers. So these are the some of the model questions, students. So you may get as a 2 marks question or 5 marks question, and sometimes two analytical constants together they may ask under 10 marks question also. Okay, so let us see some of the 2 marks questions. So define acid value, or they may ask what is acid value, what is saponification value. Okay, so or write the significance of acid value, write the significance of saponification value, what is iodine value, or write the significance of iodine value. So like this 2 marks questions you may get. Okay, when it is asked, for example, definition, better you define it along with its formula. Okay, and when it is asked about only significance, in that case also give definition of that analytical constant, then give it significance. Okay, and these are some of the model 2 marks questions. And what is saponification value? Write its significance. Okay, for 5 marks. Similarly, what is iodine value? Write its significance and determination. So if it is asked like this also, students, at least learn definition. Anyway, you are going to learn the definition, must and should. Okay, so learn the definition and formula also. Formula is very, very important. Okay, and learn the significance. Okay, so for all the analytical constants, whatever are given in your syllabus, it is better to learn minimum these three things. Okay, because if it is asked for 5 marks, or at least if you write definition, formula, and significance, minimum 3 marks you will get out of 5. Okay, that means if you skip the determination also, provided if you are having confusion or fundamentals are not good, okay, you are not able to understand the determination part, in that case also, if you skip determination for all, but you are very much thorough about the definition, formula, and significance, if it comes for 5 marks also, minimum 3 marks you will get, provided if you are writing these contents without any mistakes. Okay, so try to do smart work rather than the hard work, provided if your aim is to only clear the exam or to get up to B grade in your final examinations. Okay, as I mentioned repeatedly in the earlier sessions also, you have to plan your strategies according to your goal. Okay, whether your goal is to just clear the subject, to get B grade, A grade, or O grade, accordingly you have to plan your strategies. So I'll stop today's discussion here, students. So if you have any doubts, you can keep your doubts in the chat. And so by today, Unit 3 is completed. So from tomorrow onwards, next 2 to 3 days, I'll be focusing on Unit 5 first. Okay, so I will cover Unit 5, cycloalkanes first. Then I'll proceed with Unit 4, polynuclear aromatic hydrocarbons. Okay, so quiz will be enabled very soon. Before you attempt a quiz, okay, once revise today's concept for about 10 to 15 minutes, then only you attempt the quiz. Now let us meet in tomorrow's session. So if I have missed any of your questions due to the flow of today's session, so please join in that WhatsApp group, okay, and post your questions. Definitely, I will clarify all your doubts. So let us meet again in tomorrow's session. Take care.